Welcome to today's video on comparing the two methods, slope-intercept form and point-slope form. So let's review slope-intercept form first. The equation is y equals mx plus b, where m is the slope and b is the y-intercept. So slope-intercept form is the best to use when you have these two things, when you have the slope and you have the y-intercept. So best to use when you are given slope and y-intercept. That's really the easiest way to use that one. So if you're given slope and y-intercept, you just plug them in to their appropriate spots. The y-intercept goes in for b, and the slope goes in for m. And then very simply, it's just y equals m, which is 2, x, plus b, which is negative 3. So y equals 2x minus 3. Okay, so that's if they give you slope and y-intercept. If you're given 2 points, you have to start by finding slope yourself. So it's y2 minus y1, so 3 minus a negative 3 becomes plus 3, over x2 minus x1, 4 minus 2. And that reduces to 6 over 2, which reduces to 3. So the slope is 3. But we don't know the y-intercept. So what are we going to do with that? So this one is not the best. I would not do slope-intercept for this problem, but if you had to, we're going to do it in point-slope and convert it to slope-intercept. Okay, so remember point-slope is y. We're going to pick one of these points. I'm going to pick the first one. It's y minus y1, so y plus 3 equals m, which is 3, times x minus x1, which is 2. And then remember how we convert it to slope-intercept? We distribute the 3, so you're at y plus 3 equals 3x minus 6. And then you draw the wall and subtract the 3 to the other side. And you end up with y equals 3x minus 9. That's really the easiest way to do it. Okay, now let's talk about when point slope is more useful. Okay, so point slope is the most useful. Actually, let's write its equation first. We just did it. It's y minus y1 equals m times x minus x1. And remember, m is the slope, and x1, y1, that is a point that's given to be on the line. Okay, and just like before, this is best to use when you have a point and a slope given. So best to use when you are given a point and a slope. Duh, because it's called point-slope form. So that's the easiest way. All right, so an example, if they give you a point and they give you a slope, let's just plug the pieces into our formula. So the point is x1, y1, and the slope is m. Let's plug them in. So y minus 3 equals m times x minus 2. That's it, right? These are really easy. You just plug them in and you stop. Now, if they give it to you in function form, I would rewrite them as ordered pairs. So remember, this is x, this is y. So it's 2, 3 and negative 4, 15. Those are your 2 points. And then we have to find the slope and pick a point to plug in. So let's calculate slope. It's y2 minus y1. So 15 minus 3 over x2 minus x1, negative 4 minus 2. And that gives us 12 over negative 6, which reduces to negative 2 for the slope. And then you're going to pick one of the points. I'm going to pick the first one. So here's my point, and here's my slope. Let's plug it into point slope formula. So it's y minus 3 equals negative 2 times x minus 2. That's a point slope form. All right, so those are when to use each method. Now we're going to look at some problems, and you're going to decide which method you want to do and do it that way. All right, so number one, which method would we use if they give you a point and a slope? Should we use slope-intercept method or point slope method? Well, it says point slope, so we're going to use point slope method. Okay, so again, it's y minus y1, so y plus 5, equals slope, which is 2, times x minus x1, which is 4. And remember, in point slope, you are done right there. Now, number 2, they give you the slope and the y-intercept, so we're going to use slope-intercept form, y equals mx plus b. Okay, so y equals mx plus b, it's going to be y equals 2x minus 5. That's the m and the b plugged in. And you leave it like that. Number 3, they give you 2 points. And if they give you 2 points, it doesn't look like we know the y-intercept, so I think we're going to have to do point slope. Okay, so let's start by finding the slope. The slope is found by counting rise 2, run 3. Okay, so our slope is going to be 2/3. And then you guys get to pick your favorite point on the graph. You can do 4, 0, or you can do 8, 2. And I'm going to do 4, 0. Your choice. All right, we have a point, we have the slope. Let's plug it into point slope formula. So y minus y1, so y minus 0, equals m, which is 2/3, times x minus x1, so x minus 4. And again, leave the formula like that. If you picked this point, you would have got a different formula. That's okay. Okay, now these say write it in slope-intercept form. So we got to start with point slope and work our way to slope-intercept. Okay, so if you're given a point and you're given a slope, let's do point slope form first. So it's y minus y1, so y plus 3, equals 1/2 times x minus 2. That's point slope. But to write it in slope-intercept, we have to distribute the 1/2. So we have y plus 3 equals 1/2 x minus 1. And then to actually get y totally alone, we have to minus 3 from both sides. And that should be our answer. Y equals 1/2 x minus 4. That's slope-intercept form. And then lastly, number 4, again, feel free to pause it if you want and try. You're given 2 ordered pairs. This one is 2, 3, and this one is -4, 15. We're going to do the same thing we just did, but first we have to find slope. So again, y minus y, so 15 minus 3, over x minus x, -4 minus 2. And that reduces to 12 over -6, which is -2. All right, we have the slope, and we have a point, your choice, pick one of them. Now we're going to do point slope form and convert it to slope-intercept form. So point slope is y minus y1 equals m, which is negative 2, times x minus x1, x minus 2. But the directions say write it in slope-intercept form, so we need to distribute, and we get y minus 3 equals negative 2x plus 4, and then to officially get y alone, we're going to have to add 3, add 3. And if you do that, you get y equals negative 2x plus 7. That is in slope-intercept form. All right, thank you for watching.